I start with the point 2, 5, negative 4 and the point negative 1, 11, negative 1 in three-dimensional space. We want to draw a picture that indicates how these points are related. So I'm going to note that from 5 to 11 is a distance of 6, a displacement of 6. We have to go plus 6 units to get there. Now I'm going to use a standard orientation for the X, Y, and Z directions, and I'm going to draw a line segment of magnitude 6 in the Y direction. That'll get me from Y equals 5 to Y equals 11. Then I'm also going to draw a line segment in the Z direction that gets me from negative 4 to negative 1. Now from negative 4 to negative 1 we've got to go up 3, so we're going to move 3 units in the vertical direction, in the Z direction. And to get from 2 to negative 1 we got to go 3 units in the negative X direction, so that's going to take us from here to here. To get a picture of how those displacements are oriented in X, Y, Z space, I'm simply going to complete a rectangular parallelepiped, a rectangular solid, to represent those displacements. Now, if we want to know how far it is from this point to this point, we can start by asking ourselves, how far is it from this point to this point at this lower corner? Okay, to get from here to here we have to go 6 units in the Y direction, negative 3 units in the X direction. Now all the angles at the corners of this box are assumed to be right angles, so that this vector is going to be the hypotenuse of a right triangle, and we can bring that out into a flat plane and see that this distance, or this displacement, is negative 3. This displacement is 6, so this is the square root of 6 squared plus 3 squared. We know that squaring a negative, the negative is going to square out, so we can just write it as 6 squared plus 3 squared. Now we construct another displacement from here to here, and we move from the lower front corner to the upper back corner of the rectangle and ask ourselves how far this is.